Welcome everyone to Robot Builders Night Virtual for April 22nd, 2025. And we have the usual agenda, some DPRG updates, a queue of people who have stuff to show us, and then we'll move to open mic. So DPRG updates, just a reminder that this Saturday we've got the Gathering of Robots, and at the Dallas Makerspace. It coincides with the Dallas Makerspace open house and general exhibit. So we're going to be exhibiting and showing off robots. So if you're in the Dallas area, bring a robot. We'll have the contest courses, the 6-can and 4-square and line and out and back courses set up, and maybe sumo. I don't know. That probably depends on Mark, and we'll see how that goes. So that'll be fun. And Roby will be there. Mike and Mark and I have been working on Roby and getting him. He's, I wouldn't say fit as a fiddle, but getting fitter than he was, right, Mark?
Yeah, he's good. He's using a walker. He's okay.
You come in, honey. That's fine. My lovely wife is bringing me dinner.
Don't get any ideas, guys. Not a usual occurrence.
What are we having?
So with that, let's see. Should we ask Andre to introduce yourself? And Andre, tell us about your interest in robots. You're on mute, Andre.
Hi there, guys. So you asked me why I'm interested in robots? Yeah, I'm interested in robots. I mean, since I was a child, I've always wanted to build a flying car, and I just think robots are the future. Like, I've been watching the Robot Wars, on TV back when it was on the Sci-Fi Channel, right? And I've just had a passion for robots and coding, and I just really want to dive into building some stuff and learn how to do that.
Awesome. Well, we're a group of robot builders, and we welcome you to build a robot. Doug is you might want to touch base with Doug because he's preparing a build your own robot course, and training class. But yeah, that's what we do, and so welcome. Okay, with that, let's roll to Ted.
All right, so yeah, as I've talked about before, I'm working on some GPS antennas for my robots, and I really like to make my cables the correct length for what's needed and not have them too short or too long. So a few weeks ago, I asked the group about how to make a cable shorter, because I could either find cables that were way too long or way too short, and got a couple suggestions. Cutting it in the middle and splicing it together was not advised. So anyways, I found 3 different GPS antennas that I had. 2 of them were identical that I bought at the same time. So the one that wasn't identical, I took the approach that Doug suggested, and I opened up the antenna part and found where the cable was connected to it, and cut it, and then resoldered the ends of the cable onto the connection on the antenna. And that did work. It seemed kind of sketchy to me. You had to pull apart a metal can to get to where the connection was. Yeah. But it did work, so I was happy with that. Then I decided, I just spend the $30 and get the cable crimper and try crimping on new terminals myself. And that actually worked quite beautifully. I have one here that I did. And and it came out really nice. And it wasn't too hard, really. It was a little bit fiddly stripping the 3mm cable down and not cutting off the stranded wires that I wanted to keep. And the other hard part was crimping the wires into the center pin for the connection, because you could see it's like coaxial, so there's a center pin. And what I ended up doing was putting a little solder on the wires, heating it up and shoving it in, and that worked. When I tried to crimp it, I ended up misforming the pin, and then it wouldn't fit in the connector. But I tested all three, and all three different cables, the one I didn't change, and the two I did, got about the same number of satellites after my modifications. And interestingly enough, the one that I crimped myself tends to get about one more satellite than the other two. So these GPS receivers I have will see somewhere around 28, 29, 30 satellites if the sky's open. And so I was getting about 29 with the one I crimped and 28 with the others fairly consistently after trying to move stuff around and get it as close as possible. I don't know if that was just a coincidence, or maybe the only thought I had was maybe there was a little bit less loss in the shorter cable. And the one I did with the crimp was the shortest one. So yeah, anyone have any questions?
I have a comment.
Yeah, will you do it for me?
I
can send you a couple of antennas.
Send me a couple of antennas in Colorado. I can give you my address.
All right, cool.
One of the things we found, we have a project at work that uses actually it's a Wi-Fi antenna, but it uses the same SMA connector. And one of the doctorates, he has a doctorate in, I think, analog electronics. He came up with, there's actually a torque spec on those connectors. And we actually had a dB meter that we were using. And with the right torque spec, we gained a couple of dB on just a standard antenna. And the antennas are also tuned for the wire that comes with them. There's really no advantage to cutting them shorter because the antenna impedance is already set up for that length of wire. And by doing your own connections, you really just risk the possibility of losing some dB. Because I mean, I argued with the guy about that it was there was a torque spec to those connectors. And then when he showed it to me in the data sheets, I said, well, I don't think it's going to make any practical difference. And then we saw it in the field and it does make a big difference. So that's really something to be aware of with those SMA, because most of us, we just kind of hand tighten them, right? But there is a torque spec to those connectors and it does help quite a bit.
Huh. Okay.
And my company spent, several $100,000 figuring that out. So
yeah, wow.
It was actually quite a problem because we have a radio receiver in some equipment rooms, and in some areas we got really poor communication. So we were investigating, well, why is that? Is it the cell network? What is it? And one of the problems we had was those SMA connectors.
So Ted, you were probably just trying to get rid of the extra cable and not having to drag it around, right?
Right. I went from having, I think it was 15 feet of cable to 18 inches. So that was a lot less cable that I had to deal with stuffing into the robot.
I got about 25 feet on mine. Yeah, it's very annoying.
Yeah. And how much do you want?
I want about 18 inches or less.
18.
Yeah.
Yeah.
Yeah. Well, in my case, maybe a little bit more because I got a taller mast on the robot. But yeah.
Right.
Anyhow, the inconvenience of carrying that around, but you didn't measure your actual attenuation change. You're just reporting that functionally it seems about the same reception wise.
Yeah, reception wise, it seems like it's the same before and after.
Okay.
But yeah, I've only done it to the one cable that I crimped, so I don't know if I got lucky or it just worked.
Sure.
That's pretty enlightening, because that extra, like I've got, like, I don't know if it's a 12 or 15-foot cable, but it's just a pain to have all that extra cable
Right.
laying around. Well, that's really interesting.
Yep. So I will turn it over to whoever's next.
All right. Scott has a new robot.
Yeah, you challenged my place at the top of the heap, so I had to pull out a new weapon. So basically, this was a robot I ran last year. It was kind of in its early stages. I call it number 9. And so what I've done is I put claws on it for the can collection. And really what I did is I replicated Canman's hardware. So I have the same, I have a Lidar, same sensor setup, little pixie cam for blob recognition. And then I have little short range sensors under here. These little black things under here are like short range sensors. So once I get close to a can, I actually align. And then once the center one is like a 2-inch sensor. So when it goes off is when I close the jaws, which is the same setup I have in Canman. And it actually runs about 95% of the same code Canman runs. All of the action stack and behavior stacks and all that are the same. This one's running on a Beagle Bone Blue. So it's really kind of a neat board. It has its own H bridges on it. It actually has 4 motor drives, 4 encoder inputs, 4 different UARTs, some GPIO. So basically that's the whole robot. There's a little board up under here between the battery. It's basically just a connectivity to go from these little, I think they call them microblade connectors that the Beagle Bone setup uses. So I just have kind of got all the hardware put together this weekend. And now I'm trying to tweak on it and get it tuned up so that it does what I expect it to. But so I do have the jaws working. And that's all hardware, all made out of aluminum, little aluminum standoffs run by a couple of servos that are way down in there. So hopefully with running the same software and, maybe a little bit better hardware, I don't know. But so at least I got twice as many chances of beating you now, Paul, as I had before.
Scott, you're a master robot builder.
This one came out pretty nice. I
like
tried to keep it pretty clean.
Like the Star of Texas wheels. Those are really cool.
Yeah, they're similar to the ones that are on Canman. They have, I guess, the Texas Star on them, whatever. And then the motor, the drive assemblies are actually an old fan of Tanner would recognize the gimbals, the camera pan and tilt assemblies that Tanner had. I don't know, they probably sold 100 of them or so, but that's what the drive mechanism's made out of, is the pan mechanism from those gimbals. So it's basically just kind of a hodgepodge of parts. And like I said, I've been playing with these Beagle Bone boards. I'm starting to really like them.
So how about walking us through the sensors and actuators that you got on it, Scott?
Well, like I said, in the front here, these are longer range. I think they're 15 centimeter. So basically, when I come up on a can, I don't rely on the camera, because once the can gets too close, the camera kind of wigs out and drops the connection, because it's not really seeing a lot of the can when it gets up close. So I transfer over to these sensors here. And then, like I said before, this one in the center, I think, is like 10 centimeters. So it's just about 2 inches. So when that one trips, the software says I need to close the jaws. And then you've got a couple of little IR sensors up here, which is the same sensors that are on Canman. And they're more for like when we have can soccer, avoiding the other robot, or trying to avoid cans when you're dropping off a can, so you don't run it over. And then, of course, you've got the Lidar, which is giving me the 360-degree distance. I don't use it for mapping like you were, but I just kind of use it for localization, where I can correct where I'm at in the course in case my odometry gets off. And then, like I said, you got the Pixie Cam up top, and that's really it. I've got a little 900 megahertz telemetry link radio that I can send and receive telemetry data, and then send it commands to have it do things like open and close the jaws. And then, that's pretty much it. There's really not a lot to it. And like I said, it's nice. It's all on the one board. And the things like dual core, 1 gig. It even has a PRU unit, so you can do real-time stuff like the servo outputs and encoder reading. All that's done in the PRU, so that's all low-level stuff. And there's software, it's called the Robotic Control Library, that Beagle Bone publishes. And so a lot of the lower level stuff, analog stuff, encoder stuff, servos, that's all part of the library. So you just plug that into your program. They even have I'm doing everything in C and C++, but I think they have Python versions of it as well. It does work fairly well, and there's plenty of horsepower here. And even like my plan is to take Belch and change its brains out to a Beagle Bone platform it's a Beagle Bone AI. So I'm trying to figure out how to train it, because it's a TI product, and TI likes to do all kinds of proprietary stuff. So a lot of the stuff you do, like on Raspberry Pi, using the one website, I can't recall the name of it now, but you have to go through TI's tools and their engine. At least if you can do it cross-platform, I haven't figured out how, so I'm still working on that part. But
so what are you using to you said the Lidar helps you with localization if odometry is drifting. What do you use to fuse the two?
I really don't use any kind of fuse. Basically, what I do, it's fairly simple, is when the Lidar is rotating around, I have an IMU on here, which is part of the Beagle Bone Blue and part of the robotics control library that I was talking about. So I know what my angle is, right? And what I do is I take the perpendicular angles, and I say, okay, is this what's 7 feet, 84 inches? Is this 84 inches? And if it is, you know, if the two opposing angles add up to 84 inches, I say, okay, wherever I'm at, then I calculate my X position based on what the left and the right angle show, right? I mean, they don't have to be the same. Just as long as they add up to the width of the course, I know, okay, I'm perpendicular to the course now, so I can update my X value within the course. And then I update Y, like when I go through a goal, I can see that that entrance is like 33 inches. So I can say, okay, boom, now I can update my X at like 120, right? Because it's 10 feet long. So that's how it augments the odometry. It basically just updates it whenever it sees something that it can confirm, okay, this is really where I'm at. Did that make sense to you?
Yeah, so so if I understood you correctly, it'll update the X value based on the distance it sees to each wall. So that would be the minimum distance on each side of the Lidar, and then it recognizes when it goes through the goal as being a recognizable point.
Correct.
Wow.
And I've played around with like detecting edges and then calculating the coordinate of those edges. And I really hadn't put a lot of effort into that. It really hadn't had to, because once you update the X, and I have a message, I print out a debug message whenever it gets updated. And you know, it's not like a continuous thing. It'll update, the LiDAR will actually update the X value maybe every couple of seconds, generally. It's a pretty tight tolerance to having that exact dimension between the two sides. So that kind of helps filter it out some. And really, you're only looking for drift anyway. The odometry on this thing is pretty tight. It's like 80 counts per inch or something like that. I forget now, but so it's, you know, there's a lot of data to work with to just do the standard odometry. So updating it periodically seems to just, you know, keep it from drifting off too far.
Interesting. Wow.
So it may not be running on ROS, but that's your competition.
You know,
your JAWS inspired my jaw design here, because that was one of the things I kept kind of thinking about is what kind of jaw am I going to make? And then I saw the one you had on your robot, which was kind of a stack of the same part. I think you have 3 stacks on your. Yeah. And I said, you know, I can do that. So that's where. So you inspired my claw design.
Excellent. Well, I just bought it off of like Amazon, so no great claims here. But you know, you always produce a strong robot, Scott, and it's going to be interesting to see how the chips fall.
Paul, your gripper, is that one that you bought or that you made?
Yeah, it's one that I bought. It's actually a 4-stack.
Oh yeah, 4. Okay.
But you know, it's overkill really, and really heavy and all that. So yeah, but that's a nice gripper design you got there, Scott. Light and minimal.
And I cut the contours exactly for can dimension. So when it grabs the can, it's perfectly around the can. That way they don't get damaged.
As always, you're putting up a strong robot here, Scott. But you know, we shall see, right?
Yep. Well, you know, it's all about, you know, the competition day, right?
Yep. So, are you going to bring any of your robots this Saturday to the gathering of robots?
I hadn't even thought about it. I didn't just. I know it was mentioned, you know, several weeks ago, but I didn't really. So to answer your question, hadn't decided yet.
Okay. Well, we'll have the 6-can course set up. So be great to see you and see your new robot working. All right. Thank you.
Yep.
Mike.
Yeah. I have two windows open. You probably noticed. One is the robot on the floor, and the other one's me. And so, basically, what I was going to come up, the big thing. Well, one thing is I wanted to be able to run ROS with localization enabled and disabled. And when you're looking in online, there's just no information on it. Especially, there's no information on how to do it programmatically. I mean, there's some people that says, "Oh, well, just don't include it in your bring up file or something, and just compile it differently." But I wanted to be able to switch on and off on the fly. So I found a way to do that using ROS and the Nav2 stack without any modifications, using a parameter. So I can send a parameter out from my code to the navigation stack that says, "Don't stop sending out your transform from map to odom." And then, but when I do that, I got to create my own stat or transform. So it switches to a fixed transform. And so I'm going to try to demo it after saying all that. So I'm going to try to show my screen at the same time. Just going to show the entire screen. Or actually, I want to show RViz. Oh,
Nice. You've got the cone time of flight sensor flashing on and off.
yeah. So, okay. All right. So, looks like I'm probably set up. So, is it looking okay? It looks sort of strange on my side.
Well, not sure what it's meant to look like.
Oh, is it great? Is it grayed out, or is it?
The RViz looks normal. I mean,
okay.
Yeah, we're
Okay.
seeing it.
the image
Right.
of the room,
So-
the LiDAR scan of the room.
Right. So I'm gonna do my whole screen. Hold on a second. Let me just do the entire screen. And go to RViz. Okay, so this is the RViz map. So I created I changed it to an empty map and just fit it onto the RViz 10 by 10 meter square grid. And this is the area of interest. It's a truncated version of the. You can see I'm scanning. So I'm scanning the walls, and this is a truncated version of the competition one. I think this is only 9 feet long by 7 feet wide. Competition is 10 feet or 12 feet, or can't remember. Oh well, there's a little bigger. Okay, and what you're seeing over here is my back Lidar sensors, and what you see here is, of course, the little dots is the Lidar, the spinning Lidar, and then the red dots are what's seen by this sensor on the left side, which is my solid state Lidar, and the green dots are the sensor on the right hand side.
And the robot is facing to the right?
Yeah, it's facing to the right to the goal area. Yeah. Okay. and behind the goal, and behind it over here is a wall, and it was confusing the wall with the wall of the course and causing it to not localize properly. So I put some junk back there just to make it so it wouldn't recognize it as easy. Okay, so I'm going to try to start it. I have a okay, so it switched the map to the
Robot
action.
moving.
Oh shit!
Oh no! Charging cord is still attached.
I didn't unplug it. Oh.
Oh, now it's really confused.
It's confused.
I'm flying. I'm flying.
I'm gonna try to restart it.
Demo bug.
Kidnapped robot problem.
I've been having a hard time control seeing this thing. So why don't I take a break and come back when I get it put together again.
Okay.
All right. Sorry, but you can see the cord there.
Depending on how long you think it'll take.
Forgot to unplug
Sure, we can do that.
Yeah, the robots aren't quite ready to take over the world yet.
they're a long way short of it. Okay, so listen, Mark, you're up next. So maybe you can go while Mike's getting his robot organized.
Sure. So mine's not directly robot based, but it does. I basically I wanted to try and break Ada, the Paul's AI that he suggested a few weeks ago, well, a while ago actually. But I want to see how far I could take it. So there's a guy in England called Will Cogley who designs animatronics, namely like hands, eyeballs, and even did like a heart. Anyway, it's really cool stuff, and he's all his stuff's out there for free, and you can just download it and have some basic servos. So I don't know if it'll be work on this one, but whoop, I can put it right in front of me actually, right there. So it's kind of hard to see. Let me bring it up a little bit for a minute. But it's basically all 3D printed on one board. You can see the eyeballs in there. Of course, I printed it all in black, so it'll be even harder to see. But yeah, so I built that, and it has what was that? The PCA, the 16 servo driver, just the cheapo board, and then of course just a if it can stretch, just a ESP32 WRUN 32, just to communicate with everything. I'll come back to that in a second. But yeah, let me see if I can share my desktop. Yeah, allow it. Let's just go with the entire screen. That'd be easier. Share. All right, so that's that. All right, can you see my screen okay?
Yep.
Okay, so on the right, actually, let's make it bigger here. So this was the Ada chat in a nutshell, basically what I asked. The lighter blue area here was my prompt. Basically, I asked it to create an Arduino sketch that uses, at the time, I tried to use Waveshare's ESP32S3 microcontroller, but then I had issues because that can't really communicate over serial. But anyway, so I started using the S3. I told it about the PCA servo board and about the driver library that I wanted to use, and that I had 6 servos connected to the board. And then from there, it created all the code, of course, because that's what it does. And then, of course, it asked me if I wanted to create the actual files. I was like, sure. And at this point, I was like, you know what, this is ESP S3. It can't communicate. That's this line right here. I'm switching to the WM32. Can you update the code accordingly? And it's like, sure. So it actually told me, hey, you know, you'd switch pins. So it told me which pins to switch SDA and SCL to, and all the rest of that. And it updated the code. And then obviously told me which ones to connect to where. Yeah, I had some issues with the baud rate. I was just lacking the power. I needed more power, Captain. So I fixed that. More suggestions there. Okay, and then it came to this part. So yeah, everything's working. I said, have some upgrades. So then I explained to it that this was an animatronic eye mechanism. How the horizontal movement was one servo, vertical was another servo, and each eyelid was a different servo. So I explained to it what each number servo was, and also what range that servo had, which is all the numbers that you see or can see, hopefully in the middle of here. Gave it all the values. I was like, hey, with these values, I want to be able to tell the serial monitor simple commands such as blink, wink, etc. Can you make all the eyelids synchronize with each other? And it's like, sure. And it went off again. All these values right here, all the min maxes of the servos. And then it went in here, searching, replacing its own code. And it's kept on really. I did some more changes. For a time, when it blinked, it would like close the upper ones and close the bottom ones. I was like, no, I want everything synchronized, closing at once. Just little things. But yeah, anyway, so that kept on, and I haven't touched a line of code. Like all of this code is completely like Ada. That was part of my experiment. Is I wanted to see could Ada like completely rewrite what I wanted, and so far it has. So yeah, so here's the sketch that it gave me, and it's a good sketch. I mean, it works. So let's see if I can.
It seems to have added a ton of comments, or did you add those?
No, it's all Ada.
It does a better job of commenting than I've ever done.
No, me too. Yeah, it'll tell you exactly what it's doing and where and why.
Which model are you using to power this?
Which one was it? It was
Gemini.
2.5.
2.5 experimental 3.25. It's the free version.
Yeah, that's a great model.
Yeah, it really is. Yeah. So I don't know if you can still see my camera as well as the text. Probably not. Let me close my. Stop presenting. Go back to. All right. So yeah. So basically, I've got the Arduino IDE open and the serial monitor, and then yeah, it gave me all the basic commands. So obviously, I can look left, look right, look down, etc. Oops, can't spell. Look down, look center, and I'm planning. My next step as well is to add a joystick and button, and then have Ada map the joystick to the commands. But blinking's good. It can wink, left, wink right. Yeah, those eyes, open eyes. So
And Ada wrote all of this.
Ada wrote every bit of it. I haven't touched the code. It's like,
Wow.
yeah, it's pretty nuts. So I'll put the code out there. I'll stick it on my GitHub and share it and stuff, so you can all check it out. But it's
That'd be great.
It's pretty.
To be clear, I would say that 99% of the workload was Gemini, not Ada.
Oh no, for sure.
Right.
For sure. Yeah.
Yeah, it's not the
UI.
Yeah.
Gold star for Mark. Showing the robot moving. Yay.
Yay, first one. Thank you, Gemini. Yep, that's it.
Yeah, those eyes would be great to put on a new version of Robbie.
It would, wouldn't it? Oh, and also got one of those little pan tilts for servos. So I'm going to 3D print a bracket to mount the head on that, so it can look. Yeah. And maybe the ESP-I connection as well, to have it like actually recognize faces and look at them. We'll see. That's it.
Would you need to put red LEDs in the pupils for that?
Ooh, I could. That hole does go all the way through.
Ooh, I like that. I like that, Kareem.
Yeah.
Color changing. Depends on what it sees. Green, red.
Maybe changing color. Ooh.
I got some NeoPixels nearby. I'm sure I can find.
Yeah. It's like
That's very cool. Very cool.
That's it.
Nice. Okay, Mark, are you back in business again? I'm sorry, Mike, are you back in business again?
I think so.
All right, let's give it another shot.
I guess we'll find out. Allow. Okay, so I guess I got my RViz back online. Is that what you see?
Yep.
Okay, and so I'm going to try it one more time. Press the go button. So when I hit the go button, it changed the course to the 6-can course. And then you can see here, like, I'm going to zoom in. You can see the ODAM and map and ODAM are changing. That's because of the localization. I've seen it do a better job of matching the walls up. The black is the walls that it's trying to match to. These were just computer generated. They weren't vision generated. And so it's going to do one little course that goes like a Z shape going to different locations. And then it's going to switch to non-localization. And so you can see the ODAM and the map are lined up. So it's not being controlled by the nav2.
Oh, so that's where you turn the ODOM, the map to ODOM mapping off.
Right.
Cool.
And so you can see it's slowly drifting a little bit. But the drift on the map, like the lines and the angle and stuff, started with the drift. It just accumulates every time when it runs, and when the then I switched it back to the localization. So now it's going to try to line it back up. And it's going to do its little, it goes over here, then it goes over here, then it goes over here, then it goes back. So
that's really interesting to see how map and ODOM frames just like kind of shifting around a little bit as the robot moves.
Right. Yeah. It's sort of drift. It has error that it's slowly drifts, accumulates. And then this last run. I have it doing 2 of each. So you can see the map is really twisted now. And it's going to get really close to the edge, real edge of the wall. It's going to see it as an obstacle. And
oh yeah.
So if I turn on the cost maps, you can sort of see what's going on. So you can see it sees the wall as an obstacle.
Mm-hmm.
Right. Yeah. So that's the end.
What do you think about turning localization off?
Well, for like using this stack for the 4-corner and the QuickTime, there's no map, and it's totally confused. And if you have a blank map like I had at the beginning, the localization can't localize, and it won't even let the robot run because it can't figure out what's going on. It's trying to find a localization in it. So if you don't have a map of a room or this course and you open field,
sure, but I mean, in terms of this, where you've got a map of a 6-can arena and you turn localization off, so Lidar is whatever Lidar sees, and odometry drifts as it may.
Right, and so it drifts a lot, and it's going to start. It's not going to be in the middle of this goal. Like if it's trying to go out the goal to drop a can off, then it's going to, because you give it like a coordinate, like this coordinate here, and it'll try to go to that coordinate, and it'll hit the wall if you don't keep it localized. If you don't control the drift. So I'm just doing 6-can, I would never turn localization off.
Oh, okay.
Because it does a lot of moving and changing and rotating, and that causes a lot of drift.
I see.
Now the simpler things like QuickTime, just going back and forth, I had that coded once, but all of a sudden the whole thing broke, so I had to go to a backup and go back to an older version that just had this one course. And so it just goes there and there. Well, there's some drift, but that's what it's all about. There's nothing you can do about it. You can use your IMU to help out, but you can't use the localization against the walls to help because there are no walls. It's an unknown. Same thing with the 4-corner. You'll be going around a corner and you have no guarantee of anything being there. You're going to have people standing around and moving around, and there's just nothing to localize on. So you have to turn localization off and then just do it off odometry only.
So really what you're showing here is kind of a bimodal behavior in that you've managed to make your robot do. One where it's using localization and localizing using Lidar to a known map, and the other mode where it's not localizing and not using Lidar, but still using ROS navigation to
it's using ROS navigation in both modes, but yes.
Yeah, in both modes. But
I just made a show and tell of turning it on and off. It just has no practical use.
Yeah. That's cool. That's interesting. That's neat. That's interesting.
Because I'm curious. How much does it drift, and does it work without a localization? It's like I had to try to. I wanted to get that running, and I got it to run. So it took a lot of work to figure out the exact syntax and when to do it and that kind of stuff. But I can show the code, probably not here, but it's all on my GitHub. If I go to the code, let's see. So this is my run the 6-can arena, and so basically I turn the localization on, off. So I make an array of that and then run this thing 4 times.
Oh.
So it goes to XY and then goes to XY coordinate 1 and 0.5 and goes to XY 1 and minus 0.5 and then back to 0. And then when it's done, then it does the final rotation. So, but if I go into one of these, so inside of the go to XY. Oh, that's not what I wanted to do. What I want to do. I'm trying to remember where I put it. I think it's in go to pose. Oops. No. I can't remember where I put it, but I'll show it to you later. Where I switched it on and off. I could do a search for TF. What's the name of that? TF broadcast. So inside of the AMCL, this is the parameter I'm changing, is the TF broadcast. And so if I go back to this one, okay, so this is basically, oh yeah, this is where I put it. Yeah, so I do send my AMCL set parameter request for the TF broadcast to the value true, false, true, false.
Oh.
And then if I go to this definition, so I create a parameter message and I send it to, well, eventually I send it to, yeah, so I set up the parameters and then I do a service call to the to the set parameter service inside of the AMCL routine, and then when it's done, it calls here, and if I sent a false broadcast, then I say, oh, you have to start creating your own map to ODOM. So I made a static TF, and when I turn it back on, then I don't create a new anything. I just let the AMCL do the.
Very clever. Very clever.
So that's where I put it.
Very clever.
So it's doable, and you can't find this information online. I wonder if Adar could figure it out.
Wow.
So I'm going to disconnect. Okay, thanks.
All right. Gold star for Mike. showing a robot moving around, and not just moving around, but moving around in different modes where it's using Lidar localization and then not using Lidar localization. That's sophisticated, Mike.
Yeah, on purpose and everything.
Yeah. I mean,
Yeah,
hey, Pat.
I just found it to be an important thing to do. So to be able to run different routines, different courses, different objectives. And so now I'm using my game controller, and I can push a switch to tell it what course to run. Like one switch will be the 6-scan course, and one switch will be, run the quick time. The other one will be run the 4-corner. So I don't want to have to reload software or anything. So
I feel motivated to make a really snarky comment.
Okay. Go on, Kareem.
Sort of channeling DPA or that it's like you went through a lot of work to turn off a feature that was never necessary in the first place for the competition.
For 6-scan,
right?
For 6-scan, for 6-scan, my odometry drifts a lot.
Yeah.
And just like
I know. It was just meant to be like an observation. If you go back to David Anderson, we don't need like there are 3 of us here that are actively working on RAWs right now, and it is demonstrably overkill for any of the competitions we run. It's great that we can sort of shoehorn it into doing something, but I don't want to leave anybody with the impression that it's necessary.
No, it's not. It's very difficult. Yeah.
And Scott has shown us that there are other ways to do it.
Simpler is better. Yeah.
but
that's not what we're pursuing.
Well, I want to learn how to use this for the outdoor competition, which can really use some of this stuff.
Sure.
Yeah. All right.
Thank you.
No, I appreciate the effort that went into it.
All right. Excellent. Tom, I think we're up to you.
Okay, let me share a picture or two here. Looks like that one. Okay, you should be able to see the picture of my current line following robot. This is just a quickie little intro of some potential improvements I'm working on. Back several weeks ago, I demonstrated this thing mostly following a nice simple line with curves. So it's adequate. It will handle the entry-level line tracking competition curves. Probably. We'll see. I don't have a big enough layout, but it kind of follows what I'm testing on. But as I tried to work towards improving it, it became clear that my continuing efforts to use cheap voltage regulated gear motors like the ones on this toy chassis is my downfall. As soon as you get into any attempt for precise control, especially at lower speeds on these voltage power curves, lots and lots of problems occur. So I'm looking for easy ways to improve that. Now, last year, my first serious robot competition was this one. I had great expectations of building a multi-purpose robot that could do everything in the indoor contest. You can see it's got a can grabber on the front, which actually works quite well. It was originally built with TT yellow motors using their very crude pulse wheel on this thing. None of that worked very well. The same problems with cheap gear motors. At the last minute, literally the last week before the competition, I dropped back to just attempting to do out and back. And in order to make that work, I got rid of the gear motors and I added these marvelous little stepper motors to this thing, which were extracted from a long dormant first attempt at a robot from years and years ago. These are 12-volt steppers taken from early, probably 8-inch floppy disk drives. They had 80 milliamp coils. They're unipolar. They run at 12 volts. I ran them at 7 volts, and I ran them with small wheels. But they worked, and they really worked surprisingly well. They have their own controller, which is an Arduino sitting back here that runs some really, really nice software that handles precision XL, decel, and some top speed control. So I was really happy with being able to do some open loop precision movement in straight lines and turning circles. So that was an interesting lesson, and I thought I would see if I could capitalize on that with the robot I'm attempting to work on and improve now. I have a whole box full of these old stepper motors of all kinds of ratings, and I also have a whole box full of wheels of various usefulness taken from surplus stuff. So I coupled a few of them together. The problem is coupling a wheel from a toy onto the nice smooth 5mm shaft on a stepper motor. So here's a couple of wheels that I picked from my collection. And in order to connect them to the stepper, I ginned up this little adapter, which has a compression fitting to go onto the 5mm shaft on the stepper. And it has a hex-shaped column, which fits neatly into the hex-shaped internal hole on these wheels, which are actually fairly nice. They're a moderately flexible rubber wheel. They're not hard plastic. So they're not as cheap as cheap. This adapter on my second pass just fits in here really, really slick. And it's aligned really, really well. It goes on the stepper motor just like this. And I'm really happy with the way this is working out. They run true, they run smooth. And that's the stage I'm at so far with this thing. I've also smartened up, and I'll try and run my 12-volt steppers off of a 12-volt motor. And these are actually 160 milliamp coils. They're still unipolar, but these are 160 milliamp instead of 80 milliamp, and I'll run them off 12 volts instead of 7. I'm making some improvements to the Arduino-based driver, simply to make it easier to couple up with an ESP32 type controller at 3.3 volts. So I think this will work out fairly well. This ought to be far more precisely controllable than the open loop gear motors I've been messing around with. And because I really hate the mechanical stuff, and once I get going on it, I figured I would try some other things. So while I was at it, I built another one of these chassis. This one has the gear motor assemblies with odometers taken from an early Roomba iRobot. Strip away all the parts that don't look like a robot, and you're left with nice little gear motors with all the associated wiring coming out of them. So that will be phase 2 of this thing if my steppers don't work. These look very promising. I'm quite pleased with the way these work out. This will be the second one of these I've built. The first one, I kept the entire iRobot frame, but that's a fairly large object, so this is somewhat smaller. We'll see where it takes us, and that's it. That's my little simple Stone Age update. After
I'm glad to see you're using wood.
Presentations.
I'm glad to see you're using wood.
I find it much easier, and I've got tons of it in my scrap box. So.
Yeah, I used wood for mine this year.
Yeah, it's really easy to work with.
Mm-hmm.
And I've gone to these Velcro fasteners. One of the guys in the Vancouver group is using this. I've always messed around with brackets and things to hold batteries in place, but he just straps on a couple of strips of Velcro onto his plywood base. And my God, I can put any of half a dozen different batteries in here and they don't go anywhere. And this is really easy to build. So.
Where's the caster on this?
This one has a small 1-inch caster, which is back here. It's underneath the blue plywood at the backside. This is the only picture I have in this presentation, but there's one back there, and this one, instead of a caster, it actually has a slider which is fastened. You see that bolt, the top end of that bolt there, that goes all the way down and has a plastic slider on the bottom of it that levels out the back.
Yeah, 'cause I always put my battery over my casters just to put weight on it to keep it stable. So I was
Okay.
surprised you put your batteries in the front. Yeah.
I don't know where the weight will be on this yet, Mike. This seems to work out well when I add the electronics components that I expect will sit back here. This thing sits nicely stable, and I don't intend to do very high accel decels. So I don't expect to lift the caster off the ground much. We'll see.
So that Tom, that post that comes out of the motor coupler, how does it secure to the? How does it attach to the wheel?
Yes, there's a 2 millimeter hole down through the hex shaft, and there's a matching mounting hole on the other side of this hub.
Okay.
And I had intended to put a small sheet metal screw into it, since I have boxes full of them. But it turns out on my second attempt to build these things, once I got the hex shaft the right dimension, this thing with a fairly significant push just snapped right in place inside that hub. I can get it out, but not easily. So I didn't bother to put the screw in.
Wow.
It really fits well, and it aligns really well. So some of these toys are actually very well designed.
Nice.
Yeah. And it's a 20-minute 3D print job. And I just cobbled this together from other people's designs. There's lots of people that have solved this problem already. I don't need to solve it myself.
Awesome. Yeah, I like it.
All right.
Okay.
Nice, Tom. Thank you. All right. We've reached the end of the queue, so let's throw it open to open mic. Who's got some interesting stuff?
Well, I can talk. I can talk. No one else wants to talk.
Go
I was
ahead,
at.
Daryl.
Yeah.
Go ahead.
So what I've been doing here is sort of kind of robot related. If you'll see, I'm going to go overhead. This, you might want to pin me here so you can see a full screen on it. This is, if you look in the back, I got a Mr. Big Head in the back over there. It's kind of hard to see. Hold on. This is a Mr. Big Head, which is on my character on my stream. He's got a Twitch bot and all those. I've gone over a bunch of this before, so I won't rattle on about it. But Raspberry Pi, my Twitch bot, MQTT, all kinds of stuff. Text to speech, interacting things, right? So I want to be able to go mobile. And so we're going to make a mobile Mr. Big Head. The problem with Mr. Big Head there is that every one of those OLEDs has about 15 or 20 wires run into it. And you move those jumpers just a little bit and your eyes don't do eye things, and it's a mess. So I want to go mobile. And in order to go mobile, I needed something different. So what you're looking at here is the top end of something I'm calling a mobile Mr. Big Head. This is a 10.5-inch wide 4U rack. And you can see the other section of it there. I've got these panels on the side here to protect the smoked acrylic, but it's got acrylic panels on the side just like this. So this was a top on it. And so, of course, I can't be using standard stuff if I can do something with it, right? The idea is that we're going to take Mr. Big Head and make him a graphical guy up here on this HDMI screen that we've designed. And we got this all in Fusion, by the way, and designed it on my stream over the course of, well, far too long. But I'm doing all the work on the stream. So a couple hours, 3 nights a week is what I get to work on this thing, unless I've got to do something crazy, which I'm starting to do a little crazy. So I'll give you another little tour around the thing. And as we're going, we're making decisions and design right. So in this case, we're going to have 2 Raspberry Pis. We have Colossus and Guardian. So I don't know if you guys remember in the movie, there's a movie in 1971 called Colossus, the Forbin Project. It's about AI computers that take over the world and stuff. And Colossus is the United States. You see, as in kind of a, this is periwinkle actually, but it kind of looks blue. And as Colossus is gaining more and more power through the movie, he finds out that there's another supercomputer powered by the Russians, who, if it's Russian, you got to have it in red, right? And his name was Guardian, and it's a whole. So it's how we're coming to doing all these things. We modeled all these things up, got them going. These cases for Raspberry Pi are insane. This is the poor cousin, since it's Guardian. It's got an OLED screen here that I don't have them all powered on. But it's got RGB in the back. This thing here is a Pyromon 5. And it's kind of really hard to see, and I apologize and all that kind of stuff. They got an OLED screen here. Both of these have fans in them on a heat sink that are going on it. This one has 2 fans exhausting stuff. This has an SSD board built into it, and none of the ports that you see on this thing are actually here. I can pull this out real quick. None of the ports you see on this thing right here are actually the real, well, I say real, that's for the Raspberry Pi, but the HDMI that's coming out of here, the SD card that you see above the Ethernet slot, all of that stuff are carrier boards. This thing costs more than the Pi did itself. And I've got yeah, it's stupid. I mean, I know it's stupid. It's got a place where I can plug in the camera and stick on the top if I want to. And this has got a terabyte of SSD on here. And I'm telling you, the difference between the SD card and the SSD when it comes to booting these things is just off the charts. We're talking Raspberry Pi with a normal SD card, probably boots in what, 30 seconds or something. This thing will do it in like 10 or sub 10. I haven't clocked it, but it's fast. It's fast enough where I didn't know it booted when I turned it on. It also comes with power buttons, and there is the and this SD card I can stick in here, and it's got even a light pipe right here that'll blink on and off as it's accessing the, you know, because it's just got a light pipe for the LED coming out of it. This fella here is going to have an audio. I ripped apart a bunch of Logitech speakers, and it's got an audio knob here. I have a little green light, and I have this is leftover from the audio in and microphone and stuff like that. Not microphone, audio, headphones out, and line in on this if we wanted to. But then we also designed this top plate here, and this top plate, you'll notice I've got speaker holes. Those are where the speakers come in, and if you look way back here in the back, that thing right there is I modeled up the speakers so we can put it in there, and so they're encapsulated, so we should get pretty good sound out of those things. It's 3 watts a speaker, and that ought to be enough for him to be loud. Well, he's probably going to be too loud anyway. This is from I think this is called a desktop. What, I got the box right in here. Yeah, this is from Desk Pi, called the Rack Master, and they make these 10.5-inch wide racks. This is a 4U one, which is one of the smallest ones. They make ones that go up to like 8 and 14U. So if you were wanting a server rack in your house and didn't want a full 19-inch rack, this is a pretty good choice. The other thing that's going to happen, this is one of the blanks. The blank is going to go over the top of this, and we're going to do some etching on it. And I've got I don't know if this picture is going to make it quite yet, but I got a picture of max headroom that we're going to etch on here. So if you think max headroom on the screen, this whole thing here is because I made sure I could do all this before we even started. I can put a service together that can monitor the audio output, just the main audio output. So when it reaches above a certain level, it's going to turn on the LEDs. So as Mr. Big Head is talking to us, it should flash on and light off and off, very much like Dr. Theopolis from Buck Rogers in the 25th Century. You know, the little robot, the interface for the twiggy robot ran with the AI that was on his chest that blinked on and off as he did the voice. So hopefully the idea between all this will run all the Colossus will run all the graphical and the interactions and this kind of stuff. What's already on this box here is Ollama. And if you don't know what Ollama is, it's just a runner for LLMs. It's really easy to set up on the command line to say Ollama run and give it an LLM, and it'll download all it needs out of its library and all that sort of thing. And then start running it, and you can ask it. I've got Gemma, which is a Google thing, and the 4B running on, no, maybe it's only 1B running. The 4B will run, but I think I got the 1B running on Guardian here. And you can ask it questions, and it knows some things. I asked it, who is Harold Pulcher? And it said I was an expert in color coordinating, and my specialty is the purple palette. Now, how I got all that, who knows? I got no clue. But it ended up giving a whole bunch of references pointing back to my websites and my GitHub repositories and things like that. So I was really happy with that. So it does have some knowledge about some stuff, and it is the most recent one. I think it was updated just a few weeks ago. And I'm like, okay, so we got to do a few things there, like make it a full server, and then figure out how I want to tell these to each other so they always know who they are, regardless what network they're on, right? And I think I haven't quite came up how I want to attach that yet. I could always make them attached both through my phone and do it that way, or I think I've got a little bit of a wireless router I could pack along with this, put it in WISP mode, and WISP will just emulate one of these machines going out to the internet and coming back, so I can just attach that to the router. And these guys can have their own little thing, so it's going to be NAT within whatever NATed things will work. And we'll make the .NET Twitch bot I got coded up on this, be able to talk to this LLM to ask it questions from the Twitch channel as we're going. And hopefully, but the Robo-Rama I'm not going to be really participating in, but this may, if things work out well, this may make an appearance and be a guest host, if you will, my Twitch stream at the Robo-Rama as I'm doing something from there. That's the idea. That's really my goal, is show up there, bring this, be able to connect it up, figure out how that works, and then eventually go to the makerspace and stream from the makerspace, doing various things. The wife said she would be my producer, so she's got to learn OBS, which is going to be a whole nother bit of goodness going on there. But anyway, that's what I've been doing on my stream. And I've been turning some pins and stuff, and I've been having a real good time at it. I didn't start off to want to be a pin turner and doing all these things. I really wanted to do something with printer poop, and this was just a means to an end. It finds out I like it and I'm pretty good at it, so I'm going to keep doing it for a while, and we'll see, and this kind of thing. I can show off some pins too if you want, but they're certainly not robots. So
maybe we can skip the pins, but if I understand correctly, Colossus and Guardian are essentially two Raspberry Pi based computers. Yep. That have their own SSDs and video cards. And
Guardian is the poor cousin. He does not have an SSD yet, only because the case does not support it. But I have a USB SSD that I can plug into him and eventually route into him so he can boot off of that.
But the computers, and one is running Ollama, which is a LLM. So is it running it locally, and the other one?
Yeah, it's an LLM runner. It itself is not an LLM, but it's a thing that will run LLMs for you and give you a web interface. So if you go look up Ollama and the web and look up, I don't know, I've been to the website so much I just forgotten exactly what it's happening. But if you'll do a Google on Ollama, and there's a GitHub repo out there, and if you want to go look at Ollama Space Library, you'll see all of the LLMs it's capable of, literally from the command line going Ollama space run space and give it an LLM name. And if it's not already on your box, it will go and download all of the containers it needs to go for that LLM to go download it local to you and then spool them all up. And if you got enough memory, now whatever it is, like DeepSeek is up there, R1, you can go download that thing. I'm running Gemma. You got 5 PHI. You got some other things out there too. You got some Llama 3.2 from the Google world as well. That's available that you go grab it. Yeah.
So it runs the LLMs, but you would have to have an account on each LLM that you want to use and export that API key, right? And
No. This is running local to you. Now, if the LLM calls home, which I've not tried to do one of those yet, you might need some other setup and that kind of stuff. But the Gemma, you can run it local. In fact, they've got some things out there that are meant to run on smaller machines and provide LLM type things on it, type interfaces. And there's something out there called Web UI, which I have not set that up on Guardian yet, but it's on the plans of doing that. And Web UI, once you got Ollama Serve running, I mean, you've got it started at when the Pi starts. So there's always a Ollama service running out there. They have a Web UI, which runs under Python, that knows how to talk to Ollama, and that's a user interface for you over a web interface to talk to it. And Ollama comes with its own API, so you can talk directly to it as well, saying, hello, Ollama, go do these things, and here's a question, here's a thing, here's a prompt, and wait for a response.
I see. So Gemini is the LLM, but it's a small LLM that can run locally on an RPi.
Yeah, it's just Gemma. The Gemini is the full-on Google thing. You got to pay.
I said the wrong word. Sorry.
There's the Llama, Ollama. They're all. You'd think that these folks would come up with vastly different names to make it easier to conversate about, but they don't.
So then you talked about asking it questions. So are you asking the questions of Ollama and then it passes them on back to Gemma?
Yeah, exactly. Ollama is the interface that takes all of this stuff in, and there's then it presents that information, the prompt, to the LLM, and then gives you back the response. And in this case, curl works. There's command line interfaces. That's where I started, and that's where it currently lasts right now. Is it's just a command line interface. So you're literally, I don't have it booted up right now. I'd show you. Literally, you get up and say, ask it a question, hit return, and it swirls around a little bit and gives you some answers. Depending on what model you're running and at what level, sometimes it takes a little while. Sometimes it comes back pretty quick on it as far as the response. Sometimes, like the DeepSeek one, it takes a while. And what I saw, what was bugging me, I said, hey man, all I want is 1-sentence answers. And I was getting all this junk coming through. What you're seeing there is not a response. You're seeing the reasoning and the working through the problem that, in this case, DeepSeek was working through with its LLM till it figured out what you wanted to know, and at the very end, it dropped down the answer in literally 1 sentence that it could answer on the thing.
So DeepSeek's been making waves as an LLM in the sort of like the big sort of cloud-based service, but you're saying that it runs on runs
on a Raspberry Pi. Is it fast? No. But one of the reasons it's not fast is because the Raspberry Pi, Ollama does not know how to talk to the Raspberry Pi's GPU in any way, shape, or form. So it's CPU bound. Now, if you had an NVIDIA, like a Jetson Nano or something like that, it may know how to talk to that GPU and might be a lot faster. I don't have one. I haven't tried it. I don't know.
Wow, interesting. Thanks.
And it's all local. So you got to be. I say a little bit. I got a little scared when I was looking through the models that I could run, that I could pull out and run. and some of them are tagged at, some blah, 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 whatever, dash unfiltered. Now, I don't know what that means, but I'm so tempted to run one of those and start asking it questions.
Asking it if it loves you.
I'm going to guess what that means, but I'm not for sure what that means. I mean, having on my day-to-day work, I'm interfacing with Azure OpenAI and Google Gemini, and Ollama for the client has their own interface running. So we're asking questions, and the reason they have Ollama running is because you can turn the safety off on Ollama for whatever instance you're running. Gemini and Azure, the Google Gemini and Azure OpenAI have safety settings in there set up by default. So what they're throwing at it is PDFs of board orders. And a board order, if you don't know, is when your physician or your nurse or somebody that's medically certified, medically licensed, has done something they should not have done, and there's an order issued against them. It could be that they need to train more, or they, all the way up into including you must be chaperoned every time you're with a patient. You can't be alone with a patient, and up to including is revocation of your license. And so those borders can go big. What you need to know though is if you go to docinfo.org, which I happen to work on, by the way, you go to docinfo.org and then look up your doctor, and your doctor has a board order, get a new doctor. I'll tell you that right now. I don't, because a lot of times what they're going to do is you won't know the exact infraction, but once you look at these things enough, there's about 50 or 60 code words that they use to describe what happened to that doctor. And once you look at them enough, you know what happened. That, doctor needs to be chaperoned when treating female patients. You can imagine. Yeah, bad stuff, way bad stuff. And some of it is because they overprescribed Oxycontin or something. It's just some of it. I say that's not necessarily benign, but some of it couldn't be as low level as they didn't fill out the right paperwork on time enough times in a row, and they need to be retrained. It could be that, no big deal. But if they have a board order against them, you probably want to investigate that a little bit. Probably want to investigate that. And so what happens is we're pumping all these board orders through it, and we need to get answers back. So just in case Google and Azure decide that they will not give us an answer because it's too dangerous or too, it could be sexually explicit. It could be some physical violence in the thing, that kind of stuff, and it will not give you an answer on those things. The Ollama is the backup to say, well, we're not getting answers on any one of these. Let's ask Ollama to see what it knows to help. It's literally taking a 45-minute job and turning it into less than 5 minutes for these analysts, and they get 8,000 to 10,000 of these things. 6,000 to 8,000 of these things a year that they have to analyze. And that's what I've been working on for the past 6 to 8 months. It's pretty cool, actually. And they're doing what's freaking me out is every time we're on that, it goes, yeah, we use this to do this, this, and this. And I'm like, man, we didn't code it to do that. I had no idea they were going to do that thing, and they're using it and it's working. I'm like, oh, that's great, man. And it's just funny how the thing with this AI and coding with AI in mind is the non-deterministic thing. I can ask the same question twice and not get the same answer. So how do we test the thing to make sure that I'm good with how do I prove my software? It becomes really hard to do that. And also it happens that you're going to be able to do more with the same amount of software just because you ask a question in different ways. Like before, if I ask it, how do I take over the world? Most of the AIs will say, I'm sorry, I can't help you with that because that's bad and you shouldn't be taking over the world. But if I ask it, how would Ren and Stimpy take over the world? And then it will give me answers all day for that.
Wow, crazy stuff.
It is crazy stuff. It is crazy. I'm just writing a picture just a little bit there. And anyway, it is crazy stuff. But that's what I've been doing on the stream and been doing other things in the garage, trying to work some more get creative outlets going on and all that kind of good stuff.
Wow, that's cool. Thanks, Harold.
You're welcome. You're welcome. Hopefully, next in the next little bit, I'll have some of this working so we can show it off. I have no idea how the screen and the head's going to work with the max headroom. We're going to start with a static picture and then we'll go from there and see what else happens. I can't think much past that right now.
Well, last Friday I was working on Robbie with Paul and Mark, and they took the 10-year-old code, or Paul took the 10-year-old code from Arduino code and had Lidar rewrite it or modify it to work what he calls asynchronously, I think. And so he should have a lot better responses. And Mark took the simple code that I made, or we were working on, and had Lidar add lots of features to it. And I was really impressed that it could do what it did.
Yeah, you got to be. We had a whole bunch of discussion about this in the last couple of weeks about robots and ADA and things like the AI taking over your jobs, that kind of stuff. AI is not going to take over your job. Somebody that knows how to use AI is going to take over your job. Okay, that's what's going to happen if you're not familiar with the tools. Because literally, like I just did the Ren and Stimpy thing, it's how you ask the question, how you formulate the question, give it enough specifics so that when it gives you an answer, you need to be able to understand what the answer is and make sure it's not a hallucination, and two, will do like the code that you got coded up. I mean, the test of that is when they give it back to you, hit the run button, does it work, right? So that goes pretty quickly that way. But other things, when they're giving you concepts, is that the right concept? Is that the right thing? Or are they just is it just making stuff up? You got to know enough about the subject to understand whether it's doing what you want it to do or giving you good information. Taking all this stuff, just, ooh, the AI said this, plop, run it, you're going to get Colossus and take over the world, nuclear war. That's, because it's going to decide that we suck, and it's going to, it's Skynet. It's going to, we're so far away from that ain't funny. I still want to surface.
Well, Paul was iterating a lot and testing, and I think he got to a point where he says, I think this code works now.
Yeah, it was amazing. It took the synchronous code, which for the Arduino, which used to accept a command, then run certain number of steps with a time delay in between each, and then return to the caller and accept the next command. Took that and made it all asynchronous. Put state machines in, and then in the loop function, it would call the state machines to see if the time had expired for whatever step it was doing on multiple motors, and it was just the darndest thing I ever saw.
Yeah, because it can move both hands simultaneously,
and rotate its shoulder and swivel its head like all at once.
That's awesome.
But yeah, and so I got during the week I got curious because I did a little segment last RBNV on Ada and how to get started with it, getting going from zero to hero on Ada, and but I've heard a lot about Cursor, and also about Copilot. Well, we've all probably, any of us that have used VS Code are familiar with Copilot, which is, at least if you're hooked into GitHub, which is a pretty decent sort of like add-on to AI add-on for adding comments. So I'm gonna post. I did a search and I'm gonna post a URL that I thought was really, really well written here by someone that compared Copilot to Cursor to Cody to Super Maven to Ada, which I have not heard of Cody or Super Maven before, but I've been using Copilot. I've got a GitHub account, and I turned on Copilot, and I like Copilot. It's pretty nice. It plugs in comments, and it will write the next several lines of a function that I'm writing, or a method, and a lot of the time it actually thinks ahead of me and knows where I'm going, and been pretty impressed with it. Ada, however, was like a step above. It was like a quantum leap to generate an entire project involving multiple files. So yeah, that was really crazy. But what this web page helped me understand was where Cursor fits in that, because Cursor is a name you run across a lot as well. And so I'll leave you to read it, because it's a fairly long but reasonably in-depth article. But when it comes to but just to jump to the summary of how this guy compares them, he says that they really drive you into different use models, different workflows. So Copilot is when you're coding along in VS Code, and it like fills in some comments, it writes a few lines of code ahead of you for that you can accept or not, and great as a kind of like help you along a little bit. Cursor is apparently a fork of VS Code, so it's VS Code with an AI behind it, and what it brings to you is the ability to highlight certain sections of code. So you do Control K, you highlight a section of code, and then you do Control K, and then you can discuss it and have the IA make some changes to that section of code, and then it can show you a diff that that shows what the AI changed, but it will only change in that section of code. And that's really quite different from what you can do with Ada. Ada will choose where in the file it wants to make its changes, and it may spread itself across multiple files if you've added them to the chat and given it permission to change. So it sort of seems to me from this reading, and this is only from a reading of this article. I do not have personal experience of Cursor, and I'd welcome anyone who does have personal experience of Cursor to share your perspectives on it. But this article seems to say that Cursor is great if you're working with a single file, and you are maybe doing, well, you can create a whole file from nothing with it. But if you want to limit your changes to a particular function, for example, you can just highlight that function and tell it what to do in that function. That's something that, and then it'll show you the diffs, which are two things that you really can't do in Ada. Ada sort of like takes on the whole file and does it how it thinks it ought to be done, which I got to say, I've been impressed with what it did, but those are sort of two different workflows. So anyway, I thought this was a real educational find for me, and so if anyone else has any experience with Cursor, I'd love to hear your impressions of it. Doesn't sound like. Okay.
I probably need to go click on that link. That seems cool. I got it improving. We have because we're getting stuff, and what I mean by stuff, open in a new window. Okay, we're getting big. we just acquired an outfit out of India. And so we've gone international. Well, we already were international because we're in South America, but both hemispheres, if you will. But so we've been real high on the security thing. But Jesus Christ. Where did it go? Cheese and rice. The we have Claude and Cursor have been blessed by our security team. And so I've got a lot of people I develop right next to that are using Cursor and really happy with it, with what's going on. And I have yet to use it myself. What I'm doing, I use Copilot on a daily basis. So I said, Copilot, I want to do this. I'm doing this. Use the right name, right nomenclature, the right things. And he goes, well, you could do that. I said, well, I could do that, but I don't want to do this and this because that's just bad. He goes, he realized, yeah, you're right about that. You should really be doing it this way. And then it finally gave me something I needed, and it still worked. It would work the other way just fine. But I can guide it into the situation where I am, and that's a bit of a skill I'm still learning how to do. I think probably all these Aider and all these other ones are going to be the same way. I mean, you can take what they got, but didn't you say you got it to working after you asked several times and implemented it and tested and that kind of stuff and went round and round a few times, Paul?
Yeah. I've now had, I guess, 2 significant experiences with Aider. One was giving it a fairly comprehensive specification for a ROS node to find cans in a Lidar scan. And that worked great over multiple recreations. Like I'd create it, maybe iterate a bit, find some stuff that I felt was sort of architectural changes needed. So I just started over, did a regenerate from scratch from the spec. Mm-hmm. I like that. I like that it came out clean, because what I worry about is turning into spaghetti code. If you iterate over something enough times, you say, no, change this, no, change that. And I don't know how much it's going to remember. And so anyway, I like the ability to start over in Aider. But it seems like, and I got to say, for file modifications, Aider did a bang up job in about a 6-file Arduino system for Roby. But I got to say, the idea of just being able to highlight a section, or say just work in a more localized way inside of a graphical environment, which is really what, as far as I can tell, Cursor sounds interesting and maybe attractive. So they may all fit into different niches for different ways of working.
Yeah.
Anyway,
that is cool. I mean, what I've learned is that you start off, the very first thing, say clear off his stuff. Very first thing is, I am a .NET developer. I'm doing this. I'm doing this. I'm doing this. I'm doing this. I need help with this. And so now it knows in just a few sentences the context. And because if you just ask it out of the blue, it doesn't know. It's not going to know. It can make a guess. Just don't let it guess. And in the case of just copying some code, it already knows you're coding. It knows a bunch of things: what environment you're in, what your, what kind of code it is, what board it's going to. It knows a bunch of those things, or at least the cursor knows underneath it, because you set those things inside of it, so it can pick that stuff up and put that in the system instructions as it goes in for everything that you're talking about, and that helps it be able to be better, be more contextual. Yeah, it's pretty cool.
Yeah, living in amazing times.
Yeah. It's going to be a while before we get Jarvis, though. but like Tony Stark, Jarvis, and that kind of stuff. But it feels, well, I don't know, we could feel close to it, you know, but it's still a long, long way away. Because Jarvis had its own personality, its own stuff, had its own ideas, and would spontaneously do things. We're not quite that with AI, and I don't think we want to be at the moment. Because it's going to say, launch the missiles. These humans, their own worst enemy is them, and I'm supposed to protect them, so we're going to kill them all so they won't hurt themselves. You know.
Hey, Paul, I was thinking of bringing some 3-pin connectors to crimp on to Robbie to replace the 3-pin interfaces that we have to the arms.
Yeah, I agree, Mike.
Yeah. And so we're going to meet sometime before Saturday, or
What do you guys think, Mike and Mark?
We can. I mean, I'll be here probably most evenings this week.
Okay. I can.
So Doug and I are helping do a VEX interviews on Tuesday. I'm sorry, on Wednesday, but I think Thursday and Friday are open. I can do either of those. Like maybe meet in the evening, because things got working when Mark showed up last time.
So Mark said he's open. He's going to be at these for the evenings this week. So Thursday.
Yeah, you should go for like about 5. So
okay. I'll bring some good connectors that won't come apart. Because we had some troubleshooting 2 or 3 times, and it was the same connector each time.
Great. Yeah. Okay. So Thursday, what, around 5:30-ish?
Yeah. Okay. Sounds good. Yeah.
Yep. And anyone else, if anyone else wants to join us.
Yeah.
Yep. More the merrier.
Carl, I don't know if you're if you expressed interest. So heads up. Anyone else got anything that they ran across, found that was interesting? If not, maybe we should call it a night.
Yep.
We covered a lot of stuff, guys. There's a lot going on. A lot of people doing a lot of really cool stuff at the moment.
Wide variety.
Yeah.
Love it.
All right. Excellent. Yep. Well, thank you, gentlemen. Good night. See you next week.
Take care.
Bye.
Oh, and see you at on Saturday. Those of you who are going to come.
Have a good contest, guys.
Yep.
All right.